Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon.
Okay, so today we are going to discuss on two sets of example. So the first one is in this file, and the other one will be in the second file. So perhaps you are ready with the Fourier coefficients table, and also you have read through all the basic or fundamental on Fourier series.
Consider a signal given by the equation ft equal to modulus sine t with period or fundamental period equal to pi. So you need to determine whether the function is odd, even, harmonic, skew, or combination of the functions. So in order to solve this, you need to know how this sine t signal looks like, or you can also try different t values. Then you can estimate what types of signal is this. So in this discussion, I would like to use sketching as part of the solution. So basically, you should know how the sinusoid signal looks like. So for sine t, it usually looks like this. Okay, so but in this case we have the modulus. Okay, we have the modulus sine t. So when it has modulus, meaning that all the negative amplitude will be positive. So all this negative amplitude will be positive, and this one as well. Okay, so the signal looks like this. Okay, so from here you can determine whether it's odd, even, harmonic, skew, or else. Okay, so from here obviously you can notice that the signal is symmetry. Okay, it's a mirror image, and so that the signal is basically an even signal or even function. And you can see also the t, the fundamental t, repeating again and again. Okay, so this is basically harmonic signal as well. So this function is an even function because it is symmetry at y-axis, and it also harmonic signal, as you can see the repetition of the fundamental signal by the same fundamental period. Okay, so basically when you answer a question, please also provide some statement or justification to your answer. Okay, in the second question, you need to use Fourier coefficients table to express the trigonometric Fourier series of ft for up to third harmonics. When you notice third harmonic, so your n should vary from positive and negative 1, positive and negative 2, and positive and negative 3. Also when n equal to 0, so representing your C0. So as usual, you need to refer to the coefficients table. So look at the closest shape of signal to the signal you have. This is from question 1. So from question 1, you have this shape. So when you compare to the Fourier coefficients table, you may notice that full wave rectified signal having more or less the same shape as the signal you have. So from here you can determine the C0, Cn, and also the final column, the last column represent the remark. So don't forget to check the basic equation of exponential function. So from the coefficients table, you will create or you will develop Fourier series equation in exponential form. But the question asks you to come up with trigonometric form, meaning that you need to develop the exponential form first from the table, and then you can convert the exponential form into trigonometric form. Okay, so by comparing the signal in the table and the one you have, so you may notice that x0 is equal to 1 and your omega naught is equal to 2 pi over t, in which t0 in this case equal to pi. So in this case, your omega naught is 2 radian per second. Okay, next, remember the basic equation of exponential Fourier series. So it is C0 plus the summation of Cn, the coefficients Ej and omega t. So in this case, your omega equal to 2 radian per second, and n varies from 1 to 3. And then you need to look at your C0 and Cn equation. So in this case, C0 equal to 2x0 over pi, in which x0 equal to 1. And then replace this x0 as well, divided by pi 4n squared minus 1. Okay, so in this case, your omega is 2. Okay, so replace x0, omega, and omega values. So you get the general equation of Fourier series. Then you need to consider the coefficients. So this is your Cn. So you need to vary the n up to third harmonics. So this is your Cn equation. And then varies when n equal to 1. So when n equal to 1, when n equal to 1, so you got negative 2 over 3 pi. When you have n equal to negative 1, so when you have negative 1 squared, so you get the same answer. So this is the Cn for both positive 1 and negative 1. Next, when Cn equal to 2, okay, so replace n equal to 2, so you get negative 2 divided by 15 pi. So when you replace n equal to minus 2, so minus 2 squared becomes positive. So again, you have negative 2 over 15 pi. So third harmonics, C when n equal to positive 3 and negative 3, so replace n equal to positive 3 and negative 3, so you get the same Cn values. Okay, once you have the Cn values, then you need to replace your Cn into the general equation and then vary the n as well. Okay, so this is from the earlier derivation. Okay, you have all your Cn values. Now you need to replace all Cn values and also derive this exponential function by varying the n as well. Okay, so in this case, this is your C0, so this is your C1, and this is your C minus 1. Okay, C minus 1, E, replace the n equal to minus 1, positive 1, 2, negative 2, 3, and negative 3. Okay, so expand the equation. So this is for C n equal to 2. This is when C n equal to minus 2. This one is C n equal to 3 and C equal to n minus 3. Okay, so to convert the equation, now you already have the equation. Okay, from the coefficients table, you can develop exponential Fourier series equation. So to answer the question and to come up with trigonometric equation, you need to convert your exponential form into trigonometric form by using Euler's theorem. Okay, remember Euler's theorem, when you have cos theta t, for example, it is equal to E j theta t plus E minus j theta t divided by 2. But when you have a sine function, sine theta t equal to E j theta t minus E minus j theta t divided by 2j. Okay, this is the this is derived from Euler's theorem. So now when you have the exponential form, you can group the one that have the same coefficients and the same frequency values, but the frequency varies for positive and negative frequency. So group them, okay, based on the frequency values and also the coefficient values. And then from here, you can compare with Euler's theorem. So this is basically in cosine shape. So to get this into cosine, it must be divided by 2. Okay, so in this case, you need to divide this by 2. So you need to multiply here by 2. Same goes to the omega equal to 4 divided by 2. Here multiply with 2. And also the third harmonics divided by 2, multiply with 2. Okay, so now finalize your equation. So you have your Vt equal to 2 over pi. This is 4 over 3 pi cos 2t minus the second harmonics and minus the third harmonics. Okay, you can also convert this negative into positive by having positive pi phase shift. Okay, let's look at the first example. Given a signal as shown, xt equal to cos pi t plus 3j sine 2 pi t. So you need to determine the fundamental angular frequency and period of signal xt. So what is the fundamental angular frequency? It is omega naught in radian per second, and the period of signal period is t. Okay, and then the second question, you need to express in exponential form, and then you need to sketch both the magnitude and phase spectrum. Okay, the first question asks you to get the fundamental angular frequency and also the period of signal. So to start with, you need to look at the arrangement of the equation. Okay, usually the first component will give you the first harmonic, followed by second harmonics, and etc. If you have third harmonic, fourth harmonic, and so on. The same goes to when you have a graph, a single-sided spectrum for trigonometric equation. Okay, so the first signal represents the first harmonic, and the second one represents the second harmonic. So next you need to compare with general equation. So this is the general equation. Xt equal to cos omega naught t or cos omega 1 t. So in this case, this is the given equation. So you can compare directly omega 1 in this case equal to pi radian per second. Okay, so omega 1 equal to 2 pi f in hertz equal to pi radian per second. If the question asks you for f, the frequency in hertz, so you can calculate the f by dividing omega with 2 pi. So because omega equal to 2 pi f, so in this case f equal to 0.5 hertz. So don't forget you have two components to be solved. So this is the omega and the second one is the period. So you have solved the first one either in radian per second or in hertz, but the question asks you the angular frequency, so it is usually in radian per second. But if you provide both answers, also accepted. So next you need to calculate the period of signal. So from here, omega equal to 2 pi f, or it is also equal to 2 pi over t. So you can calculate your period. Okay, so t equal to 2 pi over omega, in which it is 2 seconds. Don't forget to write the unit as well. Okay, secondly, you need to express the given equation in exponential form and then sketch both the magnitude and phase spectrum. So in order to convert the trigonometric equation into exponential form, so you need to remember the Euler's equation or Euler's theorem for both the sine and cosine. And then you need to check for frequency sharing between components. Okay, look at the first component and the second component. So the first omega is pi omega 1, but omega 2 is 2 pi. So there's no frequency sharing. Okay, when there's no frequency sharing, then you can start solve the exponential Fourier series by converting the cos and sine function using Euler's theorem. So the first component is cos, so it is e j whatever in the bracket plus e minus j pi t divided by 2, and for the sine component 3j e j 2 pi t minus e minus j 2 pi t divided by 2j, and then simplify the equation. So this is your equation in trigonometric form. So next, don't forget you have two questions to answer. This is the first one, and the second one is sketch. Then once you have the equation in exponential form, then you can sketch the magnitude of the signal. Okay, so this is for positive pi, you have amplitude of 0.5, negative pi, you have amplitude 0.5 as well, and then at 2 pi and negative 2 pi, both magnitude 3/2 or 1.5. So this is the magnitude, although here is negative, but here is modulus, so you have all positive amplitude. Okay, next the phase. So you need to check each component. So the first one is at positive pi, so the phase is, the theta is 0. There's no theta, so it is 0. Same goes to negative pi and also 2 pi. So all zeros here. And last one, there's no phase here, but you have negative sign. So to convert negative sign, if you recall back in the first topic of the second chapter, there's one page, I think the last page in the first lecture notes. So when you have negative, it is equivalent to e j pi. So in this case, to convert this negative into positive, so you need to multiply this equation by e j pi. So you have e negative j 2 pi t multiply with e j pi. So you have a phase shift of pi. So that's why at negative 2 pi, there's phase shift of pi to convert the negative into positive. Okay, let's look at the second example. So given a periodic signal ft as the equation shown, so you need to predict and sketch the waveform. So what is waveform? Waveform is the signal in time domain. Okay, so the signal must be having shape, okay, depending on whatever shape it is, and it is in time domain. Okay, and then you need to justify your answer. So how to justify is by showing your calculation, your consideration, and state your assumption clearly in your answer or in your solution. So secondly, you need to write the trigonometric equation of signal ft. So the equation given is in exponential form. So you need to convert the equation into trigonometric form. Okay, let's look at how to solve the first question by referring to Fourier coefficients table. You need to predict and sketch the waveform. Okay, so let's look at the table. And don't forget to compare the given equation with general equation of complex exponential form. So you have the C0 plus the Cn, the coefficients. So obviously from the given equation, the first one is the C0 followed by Cn, Ejn omega t. So this is your Cn and C minus n, and followed by C2n and C minus 2n. So then you need to refer to Fourier coefficients table and look at more or less similar shape of C0 and Cn equation to the given equation. So from the table, these are the two signals that having the C0 and Cn more or less similar as the equation shown. So this column is for your C0 and this column for your Cn. If you look at the C0 of the full wave rectified signal, so you have the denominator as pi, same goes to this and this. Okay, so from here you can calculate the x0. Okay, so you need to check the C0 and x0 for both signal number 4 and number 5. So this is signal number 4 and signal number 5. So for signal number 4, C0 given from the equation is 2 over pi. Okay, so compared to the equation from the table, it's 2x0 over pi. So from here, the x0 equal to 1. So if you choose signal number 5, so again the C0 equal to 2 over pi. So the equation shown for signal number 5 is x0 over pi. So from here you get x0 equal to 2. But still you don't know which one is your actual signal. Okay, in the previous slide, we have considered the C0. And next step, you need to consider the Cn by using the x0 that have been calculated earlier. Okay, so again, refer to the table for the Cn equation for both signal number 4 and signal number 5. So don't forget to look at the comments or remark as well. So this equation valids for all n values, but for signal number 5, C0 will be zeros for n odd except C1. Okay, if you have n equal to 1, so C1 equal to this equation. So let's look at the given equation. So first consider the signal number 4. So from the earlier calculation, so we have x0 for signal number 4 equal to 1. So then Cn, assuming that n equal to 1, so replace the n equal to 1 into Cn equation of signal number 4. So in this case, C1 equal to negative 2x0, in which x0 equal to 1, divided by pi for n squared. So in this case, n equal to 1, and you get the answer equal to negative 2 divided by 3 pi. Okay, if you compare this one to this one, so it is more or less equivalent, or it is similar, but we need to check signal number 5. For signal number 5, x0 from earlier calculation equal to 2. So again, we consider the same n equal to 1. So now you need to replace Cn equation with n equal to 1. But don't forget to look at the remark. Cn will be zeros for all n odd number except C1. So now when n equal to 1, you need to use this equation. This is for C1. So C1 equal to negative jx0 divided by 4. J, this is your x0. divided by 4. So it's basically equal to negative 2j divided by 4. But if you compare with the given equation is negative 2 divided by 3 pi. So this is the given equation. So obviously, from the comparison, signal number 4 is the best one that suits the given equation. So next, you need to sketch the signal. Okay, first, sketch the signal from the table because we want to know which variables or parameter to be addressed in our sketch. Okay, next, you need to consider the x0 values. This is so we choose signal number 4 and then the x0 equal to 1 while the t0 you need to calculate from the omega. So from this equation, so this is E, J, and omega t. Okay, so n in this case equal to 1. So your omega 1 equal to 2. So here your n equal to 1. So your omega equal to 2. So from this omega you can calculate your t, which is equal to pi second. So here you have pi, the unit is second. Then you can sketch your final answer or final signal. So it is full wave rectified. So replace x0 with the value equal to 1 and t0 equal to pi, and the unit is second. Okay, in the second question, you need to write the trigonometric equation for the given signal. So the given signal is in exponential form. So to convert the exponential form into trigonometric equation, so you need to use Euler's equation or Euler's theorem, both the sine and cosine. So you need to derive the equation. So the first step is to group the signal with same frequency. So in this case, J2 and negative J2 and J4t and negative J4t. So group them up, and then next step you need to change the shape of the equation into either sine or cosine, Euler's theorem in exponential form. So in this case, to get into cosine equation, the signal must be divided by 2. Okay, but here there's no division by 2, so you introduce divided by 2 and don't forget to multiply on top with 2. Same goes to the second component. Okay, so the final answer, the trigonometric equation of signal ft equal to this. Okay, with that, thank you. Please proceed with the second file of examples on Fourier series. Thank you.